Okay, thanks very much. I'm just giving you a brief update on our project under the 3A sub-theme of the VMS Thematic Project. This project is involving a PhD student, Priyal Daya, as well as another PhD student, Kevin Nedley, who's assisting us greatly with the technical aspects of sample preparation. And so the idea here is to integrate our melt inclusion research focus with geochronology to understand more the evolution of VMS related magmas, specifically their metal and volatile endowment, and how those things are changing with time. So I just want to very briefly walk you through the methodology so that that's unambiguous and more clear. So as you know, melt inclusions occur in relatively inert minerals that we can study that have also very important textural information that can be derived through various imaging techniques. And so this is some examples of zircons containing very nice silicate melt inclusions, as well as sulfide melt inclusions, as well as other accessory minerals like apatite that are saturated at the time of melt inclusion entrapment. And if we combine the information we get from melt inclusions, for specifically their chemistry, combining that with the relative growth history of the host zircon, the geochronology of those various zircon growth zones, and chemistry, we have a really powerful tool that can allow us to unravel that magmatic history, something that is not really well represented in bulk rock geochemistry, because those bulk rocks are end products of a lot of different processes and are often affected by post-entrapment changes. For example, things like metamorphism and alteration are going to modify the metal contents of those rocks. And so we really have to look at melts as the source for this information, melt inclusion specifically. So there's some images there just in transmitted light, but on the bottom you can see some backscattered electron images as well as cathodoluminescence images showing you the complexity of growth zoning in typical zircon, and importantly in this case also melt inclusions numbered here from 1 to 3, representing different stages of melt entrapment from very early and intermediate anticrystic stages in the zircon right out to these very late overgrowths, these autocrystic stages. And so if we combine these things together, we have a really powerful tool. We are developing protocols now. Our first application is going to be in an upcoming article in 2022 from Priyal's project. And so we've taken several representative lithologies at different time intervals within the Abitibi relevant to the VMS districts, and we'll present first a paper in 2022 where we walk through the methodology as a proof of concept, and then a second paper which is submitted from Kevin Nedley's thesis is integrating melt inclusion in zircon petrochronology in the Deombu Scalaron district. And there Kevin has shown that we can use this approach to very accurately determine the depth as well as the duration of this very important transition from tholeiitic to alkali arc magmatism. And in that case, what the study has demonstrated is that not only is the melt chemistry quite cryptically observed within bulk rocks, we don't see the same bimodality in the bulk rocks as clearly as we do when we look at melt chemistry, but we also see evidence that it's this key alkalic magmatism that is bringing in metals, and we will have the first constraints on base metals as well as precious metals from those samples being presented. And so these will be unmodified estimates or measurements of the actual melt metal content for the Mushla complex as well as the associated volcanics in the Blake River. And then from Priyal's project, I just want to highlight a few key things that have developed. Priyal has now been working with not only unhomogenized inclusions, but also inclusions from various homogenized samples. And we've accumulated the database of host rock data, as well the whole rock data for the actual volcanic lithologies. And there are a few important themes I want to highlight. One is that when we look at bulk rock chemistry, there are, and compare that to melt inclusion chemistry, we do see many examples in lithologies, for example, in the Kidd Monroe assemblage, where we see only evidence of a single melt composition recorded, which is broadly consistent with the bulk rock chemistry for those specific lithologies. We don't see bimodality. But then there are other examples where, for example, we've looked at two lithologies, one from the Pacode formation and also the Upper Deloro, where very clearly now, after a fair bit of wrangling with the data, it's clear that we have a bimodality that is preserved in the melt inclusion chemistry, which is not represented in the bulk rock chemistry. And so a really important developing theme here is this relevance of bimodality, this relevance of zircons actually accurately recording at least two melt compositions over the history of evolution of these rocks. And obviously then a second theme developing is looking carefully at what the implications of that will be for metal fertility. And so one thing that is cropping up quite commonly within these zircon studies is that there are mineral inclusions. Some of those are sulfide inclusions. And so we have direct evidence from the zircon that the magmas were saturated in sulfide melt or sulfide mineral phases, especially during late stages in their entrapment. And so this is fairly critical because this could have one of two implications for the metal fertility of these magmas. One is that these melts, if they became saturated at an early stage, these sulfide phases are going to obviously incorporate and strongly pull out ore metals like copper and zinc and so on. And so this means that if these are present in the history of the evolution of these systems, that these may be very detrimental to the overall metal endowment of a given volcanic suite. On the other hand, the implications may swing the other direction in that the presence of these sulfides may, and we will be able to resolve whether this is the case or not, these may actually be entrained sulfides, and therefore they may have some consequence to upgrading or increasing the overall metal endowment of specific volcanic assemblages. So these are the two main themes we're exploring. Upcoming research activities, Priel has been working very hard, and we're very much looking forward to generating our first full data set from laser ablation work. This will be done in Geneva this coming January. We're going to look at major and trace elements as well as ore metals in zircons assembled from 22 different lithologies. Shortly after that, Priel will be going to Memorial to work with Steve Piercy and his postdoc to look at the host zircon chemistry and to do preliminary uranium-lead age screening of the zircons that contain the melt inclusions. And then we're going to be doing more focused CAID TIMS and shrimp to resolve small differences in age between specific autocrystic and anticrystic growth zones in the zircon. So that's all I have to report, just a quick update.
Thanks, Jake.
Yeah, one question I have that Jacob mentioned was that we're showing the TAS diagram with the melt inclusion chemistry and the bulk geochemistry. And I wonder if a TAS diagram is really sufficient to show the similarities or the differences between those two very different compositions. And something like a multivariate approach, such as the examples of principal components we've just seen, and some others previously, might be a better way to look at that.
Yeah, I totally agree. We're at the moment just working with major elements. We don't have any trace element data yet. And so once our database grows, we're certainly going to go beyond a TS diagram. We just use it as a very quick and simple grouping tool, but 100% agree with you.
Thank you.
Yes, thank you, Rob. Thank you for the presentation. I just wanted to add that last year I was working on a numerical model to look at the differentiation in TTG suite. This is under review by your Journal of Petrochronology at the moment. So when I saw your talk, either on melt inclusion or the first talk of Harold regarding differentiation, I thought that this could be useful to you. So I can give you more information if you like, maybe in another setting.
Thanks, Lucy. That would be great. We've been meaning to chat with you for a while about this theme, so maybe we can go offline to email and go back and forth a bit. Thank you.
That's perfect. Anytime. Thank you.